Okay, moving to the next question. Okay, so the next question shows the stress strain curve for a given material. So, what are the Young's modulus, and also we have to find the approximate yield strength of this material. So, we already know, right? The Young's modulus is given by the formula stress by strain. So, you can see the graph. Okay, so what is the value of any slope we can take? Okay, so I'm just taking now 150. Okay, so 150 into 10 to the power 6, okay, divided by 0.02, that will be the y-axis strain. So in x-axis it is clearly mentioned as 10 to the power 6, so 150 into 10 to the power 6 divided by 0.002. So just solve this equation. Okay, so you'll be getting the answer as 75 into 10 to the power 10 Newton meter to the power minus 2. So yield strength, what is called yield strength? It is a maximum stress that the material can sustain. Okay, from the graph, the approximate yield strength will be 300 into 10 to the power 6 Newton meter to the power minus 2, because after 300 the graph is quite bent. So therefore 300 into 10 to the power 6 Newton meter square will be the answer. So moving to the next question, the stress strain curve for the materials A and B as shown in the figure. Okay, so you can see the figure A and figure B. From this we can clearly understand the material is holding certain stress, and after that it is bent. Okay, so let's go to the question. The graphs are drawn to the same scale. Okay, which of the materials have the greater Young's modulus, and which of the two is the strongest material? So from the graph we can note that the stress for A is more than that of B, hence Young's modulus is greater for A than that of B. And strength of the material is determined by the amount of stress required to cause fracture. This stress corresponds to the point of fracture. The stress corresponding to the point of fracture A is more than that of B. So material A is stronger than that of B. So moving to the next question, read the following two statements carefully and state whether it is true or false. If it is false, what is the reason? If it is true, also give reason. See the question. The Young's modulus of rubber is greater than that of steel. Absolutely it is false, because it is defined as stress to the strain with elastic limit. For a given stretching force, elongation is more in rubber and quite less in steel. Hence rubber is less elastic than steel. So stretching of coil is determined by its shear modulus. That is true. Stretching of coil is determined by its shear modulus. When equal and opposite forces are applied at the opposite ends of the coil, the distance as well as the shape of the helicals of the coil change, and it involves a shear modulus. Okay, so this is what is happening in this Young's modulus. So you can expect a lot of questions like this, but you have to compare which material is elastic and which material is not elastic. So depending upon the elasticity, we can compare with the Young's modulus formula, so that we can just apply the formula as stress by strain, and then we can come to the conclusion. And whenever you're seeing the graph, you have to note down the entrance point, the fracture point, the breaking point, and the stress up to which the material can sustain the stress and the strain value. Okay, and also you can calculate the slope. So when you're getting the slope, you'll be getting the Young's modulus of the respective material. So we can just conclude that the material is able to sustain, means the material is capable of holding these many weights. So this is the practical application of Young's modulus as well. In bridges, that in the construction that they are using, Young's modulus is used. So depending on that we have to plan accordingly and to choose the type of material, whether it is brittle, whether it is ductile, everything has to be seen. Okay, so just read the question carefully and understand the sum. Okay, so thank you all. Thank you.